Hello students, welcome to the IMS GATE Academy. This will going to be the next lecture, which is lecture number 9 here. So we have almost completed the basics of the electrical machine, all right, and we are remaining with the 2 lectures, and those 2 lectures will be related to the rotating machine, which is DC machine, induction machine, as well as synchronous machine. So whatever basic that were needed for the transformer and laws, rules related to the electrical machine, that we had already covered. So those who have not watched those lectures, please do visit the lectures, and definitely you will going to enjoy all those things. So moving ahead with this lecture, we will going to cover a 3-phase rotating magnetic field, which is one of the important concept when we are dealing with the 3-phase power. Okay, Gopal Rao, good evening, Gopal. So we are heading towards the rotating machine, in which the 3-phase rotating magnetic field is one of the most important criteria when it is comes to the motor and the generator as well. All right, so let us begin with the lecture, which is lecture number 9, 3-phase rotating magnetic field. Now here I have shown you means basically this is the front view of the cylindrical surface. All right, the cylindrical part of the machine that I have shown you in a front view manner. All right, Jaydam Jayprakash, good evening, Jayprakash. So this is a stator and this is a rotor. All right, so in the stator we are going to have a 3-phase winding, like A winding, B winding, C winding, or you might have heard like R, Y, B phases. All right, red, yellow and blue. So for the sake of simplicity, I have taken A, B and C phase. Now what about this A dash, B dash and C dash? This A dash, B dash and C dash are the part of the coil. Basically this A and A dash will going to give you a one coil. Similarly, B and B dash will going to give you another coil, and C and C dash will give you another coil. So one part, like see, this A is a conductor which is carrying a current I, and this A dash, this part, this portion is A, and this A dash will taking back the current I, the same current I. All right, so I hope you have get the idea that this is basically what two conductors which has been joined from the at the end like this. So basically this is the front view of the cylindrical. See, this is placed like a front view, and the cylindrical is what placed in a flat manner. All right, suppose this is a cylindrical, so you are seeing the front part only. All right, you cannot able to see the back part or the curved surface. So the front view I have shown here, and this is what rotor, which is basically a front view of the rotor. Now, as we know that from the Faraday's laws, a EMF will going to be induced in a conductor only if we are going to have a rotating magnetic field. So until and unless we are having a rotating magnetic field, we cannot have an EMF. And if we are not having an EMF, then current will not flow in the conductor and machine will not going to operate. So how the if the magnetic field is not going to be rotated, the EMF will not going to be induced. So how this magnetic field going to be rotate here by itself, that I will let you know. So what I will do, I will assume that this conductor A carries the current in outward direction. See, means it is coming outward from the board, or it is coming outward from this board towards me. So what I will take here, so I will take inward current as positive Okay, let me take it negative. And the outward current means outward from the board, outward current as positive. Then means outward from the board and inward to the board, that current I have taken as positive and negative respectively. Jay Prakash, sir, whether the EMF and voltage are same or is they have any difference between them? Yes, these two terms are different. Basically, a voltage is treated as a kind of battery, whereas EMF is what? This is the effect of an induction. Okay, JP, it is clear? So see, what I am going to take, I will take the current here, outward current. So basically, this will be dot. Okay, if the current is coming towards you, this means that you are seeing the front part of the arrow, like in the lecture 4 or 5, I guess, in the laws of electromagnetism, I told you that we can simply represent the current with dot or cross by the analogy of your bow and arrow. All right, so like in the arrow of the bow, if this arrow comes towards you, you will see the front part of this. So this will looks like dot, and this if this arrow moving away from you, you will see the end part which look like a cross. So using the same analogy, this will be dot, then the other end of the same coil will take the current into the board. All right, so that will be cross. Now coming back to B coil, here it will be dot and here it will be cross. Similarly, here it will be dot and here it will be cross. So basically, this current means whatever the current this conductor is taking, we will assume that IA current. Okay, let me rub this. This is not required. So let me take the current here at A phase will be IA, which is equal to Im, that is maximum value of Ia sin omega t. Done. Now similarly, phase B, IB, this I will take Im sin omega t minus 120 degree. Sir, why 120 degree? Why 120 degree? Because for the proper production of the rotating magnetic field, the current difference in terms of phase angle has to be 120 degree. All right. So if this IB will going to have Im sin omega t minus 120 degree. Similarly, IC will have the phase angle difference as again minus 120 degree. So with respect to IA, it will be what? Minus 240, isn't it? Omega t minus 240 degree, or we can write minus 240 as plus 120 degree, or Im sin omega t plus 120 degree. Done. So please remember that for the proper production of the three-phase rotating magnetic field, the current will have a phase displacement of 120 degree with respect to each other. All right. And one more criteria is that windings must be placed at 120 degree. The winding must be phase displaced at an angle of 120 degree in space. All right, in terms of mechanical angle. So see, the angle between A to B is 120 degree. From B to C, it is again 120 degree, and from A to C, again it is 120 degree. So this is what? Space angle. And the space angle is known as mechanical angle. This we have discussed in the last lecture. And the angle written in voltage or current is referred as electrical angle. All right. So all this is what? Electrical angle, and the displacement between the coil is what? Space angle. Done. So this I have taken. Now one thing we should know here, let me add a page. Okay, one thing we should know here, that the current here is what? Alternating current. For the some cycle the current will be positive IA current, and for the some cycle, means basically for the half cycle the current will be positive, and for another half cycle the current will be negative. So this is alternating. Similarly, IB and IC is also are also alternating. Whenever an alternating current are passing through the coil or is passing from the coil, then a magnetic field going to be induced in that. This we have seen, isn't it? So this IA current will be here, and the same current will be entering into the board. So by using the Fleming right hand palm rule, what will be the direction of magnetic field from this IA current? See, from IA it is coming outward, and from A dash it is moving inside the board. So like this. So the thumb will represent the direction of magnetic field. All right. So here the direction for magnetic field from the face A will be this one. Okay, so this is face A magnetic field. Okay, so what is this FA? So here FA is what? MMF. MMF is what? Is flux into reluctance. This is reluctance, or simply flux is what? MMF by reluctance. So if we are able to produce a MMF which is equal to N into I divided by reluctance, let me write small I, then we are going to have a magnetic flux, and this magnetic flux will be produced, will going to produce what? The magnetic field of lines, isn't it? So until unless we are having MMF, we cannot produce a flux, and thereby we cannot have a magnetic field of lines. So this is FA. How we have got FA? From the direction of current. And here FA is what? Here FA is what? Let me write here. This FA is what? N, which is number of turns in phase A. Let me take phase A turn is N. And IA. What is IA? IA we have taken as Im sin omega t. So this is Im sin omega t. So let me take N into Im as maximum MMF. So Fm sin omega t, where Fm is what? N into Im. Done. Now let us find the direction for MMF due to coil B. Okay, this is a coil B. So here current is outward and here current is inward. So the thumb will show you the direction of MMF, which is the vertically, not a vertically, basically it is some phase displaced. Okay, let me reduce this length. So the direction here is this one. I hope this is visible. Okay, so this is FB, and using the same concept, what is FB? FB is N into IB. So let me write it directly, Fm sin omega t minus 120 degree. Okay, this will be N into IB. This FB. And what about FC? See, here current is what? Current is outward and here current is inward. So, like this. So, thumb will show the direction of MMF. So, the direction of MMF here in this case will be this one. So, this is FC. Just a second. This is FC. And what is FC? This is the MMF due to current IC. So, this FC is equal to FM sin omega t minus 240 degree or plus 120 degree. Done? Okay, just a second. Let me make it more perfectly. Okay, I guess this is visible. All right. So, the angle here okay. So, angle, this angle is 120 degree. Again, this angle is 120 degree and similarly, this angle is again 120 degree. Done? So, what it implies? It implies that the MMF produced from the current, from the respective current will also have the phase displacement of 120 degree with respect to each other. Done? So, here for the positive current, I will take the direction of MMF like this, and if the direction of current is or if the current is negative or the direction of current is opposite, then the MMF will going to be opposite because your MMF depends on or directly proportional to current. So, whatever be the direction of current, the direction of MMF will going to be the same. Done? So, let us move ahead and let us see that what will be the magnetic field at the instant omega t equal to 0. So, let me take the first case A at instant omega t equal to 0 degree. So, what will be the value of FA? FA is Fm sin omega t. So, sin 0 which is 0. Next FB. FB is what? Fm sin omega t minus 120 degree. Sin omega t minus 120 degree. So, what is this value? Put 0 here. Sin minus 120 is what? Minus sin 120 and minus sin 60 means minus root 3 by 2 Fm. Done. And FC is what? Fm sin omega t plus 120 degree. So, this is equal to root 3 by 2 Fm. Put omega t equal to 0, you will get this value. So, here FA is 0, FB is what? Negative and FC is positive. So, using the same convention of the direction, here FB will have to be, means for FB we will have to draw opposite because FB is negative. Your teaching is awesome, sir. Gopal Rao. Thank you for such a kind word, Gopal. Alright, so moving ahead. So, your FB will be negative, so we will have to draw in the opposite direction. And for FC, the direction will be same. So, let me draw here. Okay, let me draw here itself. So, your okay, so FA is 0, FB is opposite. So, FB will be in this direction. And your FC is positive, so it is in this direction. And since you have taken the FB in the reverse direction, so please do not mention the negative sign. This will be root 3 by 2 FM. This is FB, means minus FB, and this will be FC, which is root 3 by 2 FM. And what is this angle? This angle is total 60 degree. See, this is what? FB. If you take minus FB, so this minus FB will what? It will divide this angle into half. Like whatever angle this we are having, it will act as an angle bisection or angle bisector. So this FB will divide 120, means minus FB will divide this 120 into 2 equal half, which is 60 degree and 60 degree. All right. So this is 60 we are going to have. Now let us resolve this component into two parts. All right, sine and cos. Just a second, please wait. Okay, so this component I have resolved for the MMF FC. Let us resolve this part. Let me resolve with some different color. All right. So this will split this 60 degree into again 2 equal half, because this will act as an angle bisection. Now for these vectors, or for this root 3 by 2 FM, we have two components. One is vertical and another one is horizontal. So if this is 30 degree, so this becomes, this green component will become root 3 by 2 FM cos 30 degree, isn't it? And this will be root 3 by 2 FM sin 30 degree. And for this part, for this FB, we're going to have the component as root 3 by 2 FM cos 30 degree. Just a second, this is 2, and this will be root 3 by 2 FM sin 30. So the resultant that we are going to have is only this component, because this is what? Equal and opposite. The magnitude is equal and both are opposite. So the component in the resultant will be cancelled out. So the overall resultant here, which is FR, is equal to the component in this direction, which is root 3 by 2 FM cos 30, plus again we have one more component, which is green one, root 3 by 2 FM cos 30. Just a second. All right. So let us resolve here. This will be 2 times of root 3 by 2 Fm cos 60. Cos 60 is root 3 by 2. So 2 will be cancelled out. We are left with 3 by 2 Fm. So the resultant MMF will have the magnitude as root 3 by 2 Fm or 1.5 times of Fm. And what will be the direction of the resultant MMF? Is upward. So let me draw here. Direction here is upward. MMF direction. Okay, so this is FR direction at omega t equal to 0 degree. Now let us find, or let us take the second case, omega t equal to 90 degree instant. So FA will be what? Fm sin omega t. So this will be Fm. What about FB? FB is Fm sin omega t minus 120. So this will be Fm sin omega t minus 120 degree. So this will become, put 90 degree here, 90 minus 120 minus 30. So this will be minus Fm by 2. And for FC, Fm sin omega t minus 240 degree. So this value will be what? 90 minus 240 is minus 150, and minus 150, sine of minus 150 is what? Minus sine 50. So this will be minus Fm by 2 again. All right. So here Fa is positive. So in the same direction. FB is negative. So opposite direction. And what about FC? FC is here, FC is what? Again negative. So we will have to draw it in opposite direction, FC as well. Okay, so this is Fm due to Fa. This is due to FB, root 3 by 2 Fm. Okay, one more thing. What is the angle here? What is the angle here? This is 60 degree and this is 60 degree. See, this will be angle bisection, na? So 60 and 60. All right. So this will bisect the 120 as from here at 60, and again this will bisect this 120 as 60 degree. So what is the next thing? Let us resolve this part. Let us resolve this one. Okay, let me use different color here. Okay, wait a second. Not here. Sorry. Actually, sorry. It will be here. Due to this component, okay. And this will become, just a second, this will become root 3 by 2 Fm cos 60 this time, and this will be root 3 by 2 Fm sin 60 degree, sin 60 degree. Let us resolve this one. This is root 3 by 2. Okay, wait a second, not a root 3, this is half, na? Extremely sorry, this is half. This will be half. This is Fm by 2. So this will resolve as Fm by 2 and here Fm by 2. Okay, Fm by 2 sin 60 and here Fm by 2 cos 60. And for this part, this is Fm by 2. Fm by 2. Let us resolve this one as well. This part with green color. Let me replace with green color. Okay, so this comes as Fm by 2 sine 60 degree and here Fm by 2 cos 60 degree. Done. So this part is equal and opposite. These two are equal and opposite. So the MMF due to this component will be cancelled out. So we are left with Fm by 2 cos 60, Fm by 2 cos 60. So your Fr resultant, let me write here, your Fr is what? Fm plus 2 times of Fm by 2 cos 60, isn't it? Cos 60. So this will be equal to what? 3 by 2 Fm. 3 by 2 Fm. Now this time what is the direction? The resultant direction will be this one because these two components are cancelled out. So let me draw here. This time the resultant will be like this. And what is the value of Fr? Is 3 by 2 Fm. Okay. Now let me take one more instead. Just a second. Okay, let me take one more instant here at omega t equal to 180 degree. So your Fa is equal to 0, your Fb which is sine omega t minus 120. Saiket Sarkar. All right. So what is Fb? Fm sine omega t minus 120 degree. So 180 minus 120 is 60. So sine 60 is root 3 by 2 Fm. And what about Fc? Fc is sine omega t plus 120 degree. So 180 plus 120 is what? 300. Sine 300 is what? Minus root 3 by 2 Fm. So your Fa is 0, Fb is positive. So your Fb will be here in the same direction. And what about Fc? Fc is negative. So it will be in this direction. Okay, wait a second. So what is the value here? This is root 3 by 2 Fm. And this will be this same root 3 by 2 FM. And what is the angle here? What is the angle here? This is 60 degree. Now let us resolve this root 3 by 2 FM into two parts. Alright, so let us resolve. One part will be vertically downward. Like this. Just a second. Let me use some different color. And one part will be here, which is in horizontal direction. Alright, so this angle will act, means this vertical line will act as an angle bisection. So this will divide 60 degree into two parts, 30 and 30. So this becomes root 3 2 for this component, root 3 by 2 FM cos 30 degree, and here root 3 by 2 FM sin 30 degree. Let us resolve this part. With a green color. Okay, so this will be for this component. So it becomes root 3 by 2 FM sin 30 degree, and this with for the green one, this will be root 3 by 2 FM cos 30 degree. So these two part will be cancelled out, isn't it? These two part will be cancelled out due to equal and opposite value. And your resultant FR will be what? Only by these two components. So this will be 2 times of root 3 by 2 FM cos 30. So root 3 by 2, so 2 will be cancelled out. Here you are going to get 3 by 2 FM. 3 by 2 FM. And what is the resultant direction? Resultant direction is downward. This is FR direction, which is 3 by 2 FM. Now, if you closely observe all the instant, here for the sake of simplicity, I have taken only 3 omega t value, alright, 180 degree, 90 degree and 0 degree. And in that, I have seen the direction of the resultant magnetic field as upward at omega t equal to 0. At 90 degree, it is horizontal, and at omega t 180 degree, it is downward. Alright. So, if you consider all the values of omega t from 0 degree to 360 degree, you will going to see that your resultant magnetic field rotate in clockwise direction. Alright. So, in this way, the magnetic field will going to be rotated, and if the magnetic field will going to rotate, the EMF will going to induce in the conductor. Which conductor? Rotor conductor. Alright. So, this is one concept where we have used the MMF values. Alright. So, please remember the resultant value, because in some of the state exam you may directly get the values of FR, means what will be the resultant value or the peak value of the resultant magnetic field. So, you will have to take 3 by 2 FM. Please remember this one. So, moving ahead, this is the one concept. The other concept is the pole method. Alright. So, instead of using the MMF, we could have used directly what? Current, and from the current we can get the pole, north and south. How we will going to find that? Let us see here. Let me take the current IA as Im sin omega t, IB current as Im sin omega t minus 120 degree, and IC as Im sin omega t minus 240 or plus 120, both are same, plus 120 degree. Done. So what we need to do here? Earlier we have assumed here the direction of current as dot. Please let me know whether this color is visible or not. Dot here. Wait a second. All right. This was the dot and this was the cross. Similarly for phase B, this was the dot and here cross. Because this is the conductor of the same coil. So one conductor will take the current in forward direction and other will take in the backward direction. All right. So if one is dot, other has to be cross. Similarly, here we have taken a dot and it becomes cross. So that direction we will going to follow. All right. So this will be the conventional direction. If the current value becomes negative, we will swap this two direction. All right. So let me take an instant at omega t equal to 0. Let me take an instant at omega t equal to 0 degree. So what will be the value of Ia? My friend, please let me know. Ia value will be 0. IB value will be sin omega t minus 120. So this will be minus root 3 by 2 Im. Please confirm. And what about IC? IC will be root 3 by 2 Im. 0 degree sin 120 is what? Root 3 by 2. Now, here I am very sure that Ia will be 0 and IB is negative. So, the current here has to be drawn in reverse direction. Earlier, it was dot, na? So, this time it becomes cross. Let me change the color. This time it becomes cross and this become dot for phase B current. And what about phase C? It is positive. So the direction will be the same as that we have taken. Done. In case of any doubt, please do let me know. I will happy and feel free to clarify all your doubt. All right, so moving ahead, this will be the dot and this will be the cross, and for phase A we are not having any current, so this will not going to participate in the production of magnetic field. Now, since this is the dot current, so it will going to produce a magnetic field. And how to find the magnetic field? By using the Fleming right hand palm rule. So this dot means the current is coming outward. So the forefinger will curve in the direction of magnetic field. So here direction will be what? Anti-clockwise. So this 2 will give the magnetic field like this. In the anti-clockwise direction. And what about this phase? What about this cross? Cross means current is inside. So inside, so this forefinger will curve in clockwise direction. So here current, the magnetic field is like this. Okay, so here magnetic field is clockwise. All right, so this is the stator, this is the rotor. So the gap is what? Air. The gap is what? air. Now, we know one concept of the magnetic field. The magnetic field lines move outward from the north pole, enters into the air, and from air it will again enter into the south pole. So since this is an iron core, so from here the magnetic field will enter into the air. So this behaves as a north pole. This part behaves as a north pole, and this part air, and it is entering into the iron core. This means that this part will acting as a south pole, isn't it? So the direction here, of the resultant magnetic field will be this one. Okay, so this is the resultant direction. Let us take one more instant here at omega t equal to 90 degree. What is Ia? It will be plus Im. What about Ib? Sin omega t minus 90. So 90 minus 120 is what? Minus 30. Sin of minus 30 is what? Minus Im by 2. IC. Sin 90 plus 120. Where it is written? Yeah, 90 plus 120 is what? 90 plus 120, 210. Sin 210 is again minus Im by 2. Alright, so let us see here. Ia is positive. So dot cross. Ib is negative. So cross dot. IC is negative. So this becomes cross and this becomes dot. So the upper part is what? All having the dot current. So means here current is what? Outward. So point the thumb in the direction of current. So it is outward. This forefinger will give you the direction of magnetic field, which is anti-clockwise. Always the dot gives the direction of magnetic field as anti-clockwise. Remember. Okay, so here direction is anti-clockwise. And this cross will give, means the cross here is inward. So clockwise direction. Like this. Okay, the direction that it will going to be follow is the clockwise. So this behaves as a north pole and this behaves as a south pole. So the direction that we are going to have is like this. Then let us take the last instant. Okay, just a second. Please wait, let me copy from here. Okay. Let me rub all this. This is not required. Just a second. Okay, so last instant will be what? At omega t. See, at omega t equal to 180 degree. Let us take. So your IA is what? This is 0. Your IB, Im sine omega t minus 120. So 180 minus 120 is what? 60. So this will become root 3 by 2 Im. Please check. IC, this is 180 minus 240. So minus 60. Sine minus 60 is minus root 3 by 2 Im. Please confirm, everybody. Now this IA will not give any magnetic field. This IB is positive, so here dot will come and this becomes cross. IC is negative, so it becomes cross and it becomes dot. So this dot will give the current, the magnetic field in clockwise. Anti-clockwise. See, it is outward, so anti-clockwise. Okay, like this. And for cross, the direction will be clockwise. Like this. So clockwise means this one. Okay, I have drawn wrong now, I guess. This will be anti-clockwise. Okay, this will be clockwise. This will be clockwise. Like this. See, it is inside, so clockwise direction. And that will be anti-clockwise. That will be anti-clockwise. Okay, like this. Anyway, this was the dot, I guess. Done. So this is an iron ore. So this behaves as an north pole. Behaves as a north pole, and this behaves as a south pole. So the resultant will be this one. The resultant direction of magnetic field. Done. So this is the with respect to pole concept. So here we have framed directly a pole's contribution due to the current. All right. So this is north and this is south, and on the variation of the omega t, on the variation of the angle, you will see that your magnetic field will rotate it in clockwise direction. And this is evident that whatever direction that we have got from the MMF is the same. All right. So either you go by the MMF concept or by the pole concept, you will going to see the direction of rotating magnetic field. So this is what rotating magnetic field. But what is the drawback here? The drawback here is that we cannot able to find the magnitude of the magnetic flux. Earlier in the MMF concept, we have got the MMF as 3 by 2 FM, means the maximum magnetic flux, you can say, means the magnetomotive flux, all right, MMF. So we can get the magnitude with respect to MMF concept, but if you are going to follow the pole concept, you cannot able to get the MMF value, all right. So this is the drawback of this concept, which is pole concept. All right. So one question is from my side is that how this direction means how this clockwise direction has been chosen. It is always true, or we can change the direction here. Like we can change the direction to the anti-clockwise as well. Is it possible? Yes, it is possible. How? How it is possible? It is possible by interchanging any two phase currents out of three phases, out of three phases currents. All right, so what I will do, I will take IA as it is, which was Im sine omega t. But here I will change the IB phase. All right, earlier it was Im sine omega t minus 120 degree, but this time I have interchanged the phase current of B and C. All right, so this becomes omega t plus 120 degree, and for IC we will going to have omega t minus 120 degree. So if you do so, you can able to change the direction of magnetic field, and this kind of technique we are using in our rail engine. All right, electrical range rail engine that we are having is what, if you interchange any two phases, we can able to stop the engine. All right, so this is basically known as a plunging or the braking of the system. Whenever you interchange, the machine will going to at the verge of the stop. All right. So see whether actually it is reversing the direction of magnetic field or not. Let us verify. Okay. So the sign convention that we had taken, dot cross here, dot cross here, dot here cross and dot. Again, the phase displacement among all the winding is what? 120 degree, and the phase displacement among the current is what? Again 120 degree. So all these two condition means basically these two condition has to satisfy, otherwise if any one of these two is violate, then the rotating magnetic field is not going to be possible. Am I clear? Any doubt in this? Please do let me know. So see here, the MMF that we have got, the direction of MMF, this was FA for this current, this was FB for this FB current, and this was FC for this current. All right. So if the MMF becomes negative, we will reverse the direction. Now let me take an instant at omega t. At omega t equal to 0 degree, then your your FA, let me write it directly. FA is FM sine omega t. FB, this time it becomes FM sine omega t plus 120 degree. Earlier it was minus 120. FC, this was at 0 degree na, so let me write here directly sine omega t plus 120 degree. So at omega t equal to 0, what this value becomes? This becomes root 3 by 2 FM na, root 3 by 2 FM, and your FC, FM sine omega t minus 120 degree. So this becomes minus root 3 by 2 FM. All right. So your FA, okay, wait a second, this will be 0. So your FA will be 0. And what about FB? FB is what? Positive. So it will be in this direction. And what about FC? Just a second. What about FC? FC is negative. So it is in this direction. Done. So this is root 3 by 2 FM due to FB, and this is this same value root 3 by 2 FM. Now let us resolve into the two parts. First part will be horizontal for this component. And one part will be horizontal. Okay, one part will be vertical and one part will be horizontal. And what is this value? This total angle is 60 degree. So this will be 30 degree and this will be 30 degree. So you will get here root 3, okay, sorry. This will be root 3 by 2 FM. What this becomes? This is 30 degree, so this becomes sine 30 degree and this become root 3 by 2 FM cos 30. And let us resolve this one. First one in horizontal. Let us use green color and one will be vertical. So this is root 3 by 2 FM sine 30 and root 3 by 2 FM cos 30 degree. So what is resultant here, my friend? Resultant will be FR. Okay, these two will be cancelled out due to equal and opposite value, and your FR now become the resultant MMF is now 2 times of root 3 by 2 FM cos 60. Root 3 by 2 FM cos, sorry, I have said 30, no, sorry, I have said 60, no, sorry, this is 30. So here you will get root 3 by 2, 2 will be cancelled out, 3 by 2 FM. The magnitude is same, 3 by 2 FM. And what is the direction? The resultant direction is downward. So this is F resultant, which is having the value of 3 by 2 FM. Done. Now let us take one more value, which is B at omega t equal to 90 degree. So your FA is FM sin 90 means FM. FB is FM sin omega t plus 120 degree. So 90 plus 120 is what? 210. Sin 210 is minus FM by 2. FC sin omega t minus 120 degree. So 90 minus 120 is what? Minus 30. Sin of minus 30 is what? Minus FM by 2. Alright, so FA is positive, so we will have to draw in the same direction. Your FB is negative. Your FB is negative, just a second. So we will have to draw in opposite direction. And your FC is again negative, so in opposite direction. Done. So what is this value? This is Fm. This is Fm by 2 and this is Fm by 2. And what is this total angle? This total angle is 120 degree. So the half will be 60 degree and 60 degree. This is total 120 degree and this will act as an angle bisector. So it will divide 120 into 60 and 60. So let us resolve here this Fm by 2 into vertical and one horizontal. And what will be the values? This will be Fm by 2 sine 60 and here Fm by 2 cos 60. And let us resolve this one. So this time this is Fm by 2 sine 60 degree and Fm by 2 cos 60 degree. So these two will be cancelled out, the vertical one, because of equal and opposite nature. And what will the resultant value of MMF? This Fr is equal to only due to this component, which is Fm plus 2 times of Fm by 2 cos 60. So again you will going to get 3 by 2 Fm. Now this time what is the direction? Direction will be vertical. So let me draw here. So this is Fr, which is equal to 3 by 2 Fm. Done. Let me take a last instant, means a last value at omega t equal to 180 degree. Okay, so your Fa is Fm sin omega t, so 0. Fb sin omega t plus 120 means 180 plus 120 is what? 300. So sin 300 is minus root 3 by 2 Fm. Fc sin omega t minus 120. So 180 minus 120 is what? 60. Sin 60 is root 3 by 2. Done. So here Fa is 0, Fb is negative. So opposite. Let us make it opposite. And your Fc is positive. So in the same direction we will have to draw. So this is root 3 by 2 Fm and this Fc is root 3 by 2 Fm. Now let us resolve into vertical. Let us resolve first this one. Okay, so you will get this value as root 3 by 2 Fm. Okay, what is this total value? What is this total value? This total value is 60 degree. So it becomes 30 and 30. This is total 60 degree, isn't it? So your value, this value will become Fm by 2 cos 30 degree, and this becomes Fm by 2 root 3 fm by 2 sine 30 degree. All right, and the last one will be this component. Let us resolve. Okay, so from here we will get root 3 by 2 fm cos 30 degree and root 3 by 2 fm sine 30 degree. So the horizontal component will be cancelled out due to equal and opposite values, and we are left with the resultant fr, which is equal to 2 times of root 3 by 2. These two values are same, na? Root 3 by 2 fm cos 30. So here you will get 3 by 2 fm. So the resultant here is upward direction. So let me draw. This is equal to fr 3 by 2 fm. Done. So if you see for the 3 instant, the direction of rotation, first it is downward, then horizontal, then upward. So the direction is reversed. This time it is rotating in anti-clockwise direction. So it is clear that whenever you are interchanging any two terminals current, not all the threes, only two, then the direction of magnetic field will going to be reverse. All right. Now one more question I am having. If we interchange the winding, can we have the magnetic field in the opposite direction? By interchanging the windings, I am not saying the current. By interchanging the windings, can the direction of magnetic field will going to be changed? No. The winding are always static. Only the current flowing through that winding, will decide the direction of magnetic field, not the winding. The current flowing in that winding will decide the magnetic field. All right. See, I can name this as B, this as C, this as A. All right. But in phase C, let me take the current here, Im sin omega t. Let us take this as phase A and the current here as Im sin omega t minus 120. And here at phase B, let us take Im sin omega t minus 240. Means you can name the winding at whatever notation you may like. You can give Nikhil, Akhil, Rahul. You can give X, Y, Z. You can give A, B, C or A, B, C or C, B, A. Any name you can give. But the important point is that depending on the current, the direction of rotation will going to be decided. First, you will give sin omega t. Then after that, you will have to give a minus 120 degree current. All right. After that, you will going to give again minus 240 degree current. Then only the direction will going to be clockwise. All right. If you interchange, you will going to give the you will going to have the direction as anti-clockwise. So the important point or the summary here is that for 3-phase, space angle means exactly where the winding has to be placed, it will be decided by this formula 360 degree by m, and the phase shift between the currents will be same, which is 360 degree by m. Then the MMF will have the value as m by 2 times Fm. Fm is what? Maximum MMF, which is n into Im, isn't it? And what is m? M is the number of phases which is greater than equal to 3. So whenever your phase is like 3, 4, 6, 7, 8, 9, 10, so on and so forth, you will going to use this formula, isn't it? Let me use here not 3, m. For m phase where m is greater than equal to 3, you will going to have this formula. Whereas in two phase, phase angle will be 90 degree and phase shift will be 90 degree and magnitude will be FM, the magnitude of MF. This we will going to see in the next lecture on Tuesday. All right, the timing is 4 to 5:30 for the Tuesday, which will be the last lecture of the electrical machine. Now, to reverse the direction of magnetic field, we will have to reverse the two terminal or the phase sequence out of the three. The direction of rotation can be reversed. So, if you reverse the two phases current out of the three, the direction of rotation will going to be reversed. And whereas in the two phase, the both terminal has to be interchanged or swept, then only the rotation of the the direction of the rotation of the magnetic field will going to be reversed. Anyway, this we will going to see in the last lecture, that is the two phase. But as of now, I have given you some idea. So try to remember all this thing, because you may directly get a 1 mark question in the GATE exam as well as in other state, or simply you can say AE kind of exam. All right. So please do verify the direction of rotation by using the pole concept. From there you will going to see the direction as anti-clockwise. So I have left the pole concept for your practice. Please do solve and verify with my direction. All right. So if you have enjoyed the lecture, my friend, please hit the like button and also share the session link with your friend, and do subscribe our YouTube channel, and whenever we are coming live, then to get instantly notified, definitely you will have to press the bell icon. All right. And if you want to counsel yourself, you will going to find one ribbon or a banner that is running at the bottom of this video. So you can contact to our counseling team, and definitely you will going to have a great experience. All right. And one more thing, if you want to enroll at our GATE at zero fee program, in which you will going to get some free of cost lecture and some test series also. So please enroll that. You will going to enjoy a lot. All right. And the link has and the link is given in the description box. Please go and enroll yourself. All right. So we will see you. Definitely whatever doubt you are going to have, please feel free to comment in the chat box. Whenever I'll have a free time, I will go through that, and I will try to resolve as early as possible. All right. So let us end the lecture, and we'll meet on the Tuesday. The timing will be 4 to 5:30 p.m. So bye bye, and take a very good care of your health.